Section 2.5 is where we are going to solve systems algebraically. So that means we will either solve the system by substitution or by elimination. So this first example, showing you how you will be given a system that you're going to solve by substitution. You want to solve one of the equations for one of the variables. So you can choose. So typically what I tell my kids is pick a variable that doesn't have a number in front of it because that would make it the easiest. So this one down here would be the easiest to solve, and it would be the easiest to solve for x because all I would have to do is minus my 2y to the other side. So that's what I did first. I went ahead and I took that 2y and I minused it over, so I got negative 2y equal to 12. Once you have your equation solved for a variable, so I use this bottom one, so I'm going to cross it off. Once I have used that and transformed it so that it's solved for x, I'm going to replace that expression into my other equation for the x spot. Okay, so that means that I'm going to take my top equation, 8x minus 3y equals negative 1, and I'm going to replace the x with this new expression. So that's what I'm doing here. I'm substituting in. And then from there, you're just doing your normal solving. So you would distribute your 8, so you would have negative 16y minus 96 minus 3y equals negative 1. And then you would start solving. So I would get negative 19y minus 96 equals negative 1. Then I would add over that 96, so I would get 95. And then I would divide, and I would get negative 5. Okay, once you have that answer, you want to go back and plug it in. You can plug it into either original equation, or you can even go back to the one that you had solved for. I like to go back to the one I solved for because it's just a little bit less work for me. So I would go back to this one up here, and I would put in my negative 5 for my y so that I can find my x coordinate now. So I would do negative 2 times negative 5 on my calculator, which is 10, minus 12, which is negative 2. So my x coordinate would be negative 2, and my y coordinate would be positive 5. So then I can write my ordered pair. So negative 2, negative 5. All right, I'm going to have you try one of those. So see if you can take this system and solve it for the x and the y. So in this example, you can solve either equation. What I would do is I would look for one that doesn't have a number in front of it. So that would be this bottom one. So I would take that equation and I would minus my 3x over. So that's what I did first. And then I came through and I divided everything by negative 1. If you can find the one that doesn't have a number in front of it, it makes things a little bit nicer because then you don't have fractions to deal with. So then I'm going to cross off this equation that I just used, and I'm going to plug this into my top equation. Now, since I solved for y, I have to plug this into the y spot. So that's why I wrote over here 6x plus 5, and then in place of the y, I got 3x plus 11 equals negative 8. So then I would distribute, combine my like terms, move over my 55, and divide. So if you did it correctly, you should have gotten x to be negative 3. Then you can go back and plug it into either original equation, or you can come down here to your solved equation. I like to go to the solved one, so I did 3 times negative 3, and then I added 11, and I got positive 2. So then I just put it together and write it as an ordered pair. Okay, so then we're going to keep practicing this. So on this example, notice that they've already solved the bottom equation for y. So they've already taken care of my first step. So I'm ready to just start plugging it in. So that's what I did first. I took this guy and I plugged it into that top equation for the y spot. So then I did my normal solving. So I distributed, and then I combined my x's. Once I combined my x's, I noticed that they canceled out and I didn't have any x's left over. If your variables cancel out, this is an option where it could be no solution or it could be infinitely many solutions. So since these are not the same, this is not a true statement. This is false. So therefore, since it's false, it is a no solution. So remember when we were solving by graphing, we could have 0 solutions, 1 solution, or infinitely many. This is an example where you can see that no solution when you're solving it algebraically. So let's take a look at another example. So here's another one where the bottom one is already solved for y. So again, I'm going to take that guy and I'm going to replace it into that y spot. So then I have this equation. I'm going to distribute and combine my like terms. After I combine my like terms, my x's again canceled out. So in this case, I got 4 to equal 4, which is a true statement. Since that is true, I would have infinitely many solutions. In this unit, we are also going to look at writing equations based off of a word problem. So I'll give you a second to read through this scenario. In this scenario, I highlighted some important information, which you see in red. Totals are always going to go at the end. So I know that I'm going to have to total to 300. So I'm going to have my x and my y add together to equal 300. I also know that I'm trying to figure out how much of each of these I need. So that's what my x and y are representing. So since they're percents, I'm going to change them to decimal, so 0.035, and then 0.07 for the 7%. Now this one's the kind of tricky part from chemistry. We are wanting 5% of that 300, so you do need to calculate 5% of 300, which means you need to times 0.05 times 300 to figure out how much of that solution we're trying to get. Once you have your equation set up, then it's not so bad. So kids kind of struggle with the setup. So I went ahead and solved the top equation for y, so I just minused my x over. And then I substituted it into that bottom equation for the y spot. So then we can distribute, combine like terms, move our stuff over, and then divide. So this was about 171.4. I plugged it back into my solved equation, and I found that I had 128.6. Now the tricky part is making sure you remember which one is which. So my x went with the 0.035. So that means this number was how many milliliters I needed of the 3.5%. And the y went with the 7%. So the 128.6 is how many milliliters I needed of the 7%. Pause the video and try this next question. So in the next question, you would have found that the player gets 5 points when they defeat an enemy. They also get 1,000 points when they take a castle. I see that you have a total of 10,800 points. I also see that 160 times more enemies than castles have been conquered. So first, I see a total. So that always is going to go at the end. I'm going to get that total by using these point values. So 5 for enemies and 1,000 for castles. This other one is a little trickier because you have to think through what you're doing. I know I'm doing 160 times, okay? But I need to figure out which one I'm going to have more of. Am I going to have more of the enemies or more of the castles? And they're saying you have more enemies than castles. So the enemies is what's going to be equal to me doing 160 times my castles. Once you have that, then you can start solving. So I would use substitution. This one is already solved for E, so I can substitute it in there. And then I can times, combine my like terms, and then divide. So this is saying that I could have 6 castles. And then if I plug it back into one of my equations, you would end up finding 960 enemies. All right, so that takes care of substitution. And so the next part is going to be elimination. So the second part of 2.5 is where we're going to solve systems by elimination. So here's an example where you have a system of equations and you want to solve it by elimination. So what that means is you want to add these two equations together. So either the x's will eliminate, meaning they'll add to 0, or your y's will eliminate, which means they would add to 0. Currently, right now, if I added the x's, I would get negative 6x. If I added my y's, I would get negative 18y. So neither of the variables will eliminate. Since they won't eliminate, it is our job to transform our equations so that they will eliminate. So what that means is you can multiply to get these numbers the same, or you can multiply to get these numbers the same. Since my y's are already the same number, all I would need to do is just change one of these two signs so that one would be positive and one would be negative, and that would make them add to 0. So if I take this bottom equation and I times by -1, that will change all of my signs to make it become positive. So then I can add negative 4x, positive 4x plus 9y equals 23. I can take that equation and add it with my top equation. So once I do that, my y's now add to 0. My x's will add to 2x, and my constants will add to -2. So I always want to set it up so that you can get either your x's or your y's to add to 0. Once I've done that, then it's just a simple equation to solve, so I can divide by 2 and found my x is -1. Just like substitution, you will want to plug that back into one of your equations. So you can pick either original equation and plug it back in. So I just picked the negative 4x plus minus 9y equals -23. So after plugging that in and solving, so positive 4 minus 9y equals -23, I would minus that 4 to the other side, and then I would divide by my -9. So I would get positive 3 for my y. So I would write my answer, -1, positive 3. All right, let's take a look at another example. So as I'm looking at my system here, I notice that my x's are not the same, but my y's are the same. So what I can do is, since the y's are already the same, I can just take one of my equations and times by -1. So I left the top equation the same thing, and then I times the bottom equation by -1. So I got -7x, -2y, and -24. Now I can check. If I add my y's, do they add to 0? Yes. Positive 2 plus -2 is 0. So then I'm going to add my x's. 8, -7 gives me positive 1x. 30 and -24 gives me positive 6. I'm done because x equals 6. Just like substitution, you're going to plug it back in to find your y variable. So you can pick either equation. So I went ahead and used the top one. So I put in 6 for x plus 2y equals 30. I then went ahead and solved. So times them, subtract 48, divide by 2, and we found that y was -9. Finish by writing your answer as an ordered pair. Okay, so looking a little bit further here. So here we have an example where neither the x's or the y's end up being the same number. So here's an example where you might need to, and you will, multiply both equations by a number to make these become the same. So you want to make these become a multiple of 2 and 3. So for example, a number that 2 and 3 go into is 6. So I want to change these to become 6. Or I could change the y's and make them both become 20. Sometimes people have troubles finding what those multiples are. So one trick is you can always just flip-flop. So if you want to get rid of the x's, you can multiply the top one by 3. And if you want to get rid of the x's, then you would multiply the bottom one by 2. If you were to get rid of the y's, then I would use 4 on the top and 5 on the bottom. It is your choice which way you decide to do this. Now, I went ahead and also multiplied the top equation by a negative because I noticed that one of them is not negative. So you need one of them to be negative in order for them to cancel out. So if you were doing the y's, one is already negative, so you would not have to put a negative on either of them. All right, so once you can figure out what numbers to multiply by, then it's the same process. So you'd go ahead and multiply through, so -6, -15, -3. So notice I'm going all the way through that equation. And then down here, positive 6, negative 8, negative 20. When I add my x's, negative 6 and positive 6 add to 0. Add my y's, I get negative 23. Add my constants, I get negative 23, and then I can divide. And then just like substitution, plug it back into one of your equations. So I just picked the top one, and I'm going to plug it back in for the y spot since it was y equals, and then start solving. So times minus your 5, divide by 2, and then write it as an ordered pair. Pause the video and try the got it question. So in this one, again, I decided to get rid of the x's, so I went ahead and multiplied by 5 and 6. And then when I multiplied out, I got my y to be equal to negative 4. And then I substituted back into my top equation, and I got negative 2. If you were to get rid of your y's, you would just have to times the top one by 9 and the bottom one by 5. All right, let's look at two more special cases here. So you're going to start these the same way. So this top equation is not going to change. I'm going to go ahead and get rid of the x's on this. So I'm going to times this bottom one just by 3 since I will make it 18. And I'm also going to times it by a negative. So the top one didn't change. The bottom one, I'm timesing everything by negative 3. So my x's, they added to 0, but also my y's are adding to 0. So notice, if your variables cancel, just like in substitution, if they canceled, you have a special case here. So you're going to check to see if this is true or false. Is 0 equal to 8? No, this is false, so this is an example of a no solution. So one more special case here. So doing it again, take the top equation. I decided to get rid of the x's, so I times the bottom one by 3, so these would match. So I have these equations. When I add them together, my variables canceled on x's and y's, so I got 0. And my constants also gave me 0. So since that is a true statement, that is infinitely many solutions. So that's how you're going to solve by elimination, and then they will scatter through there those no solution and infinitely many solution answers.